Hi everybody. Welcome to the part 3 of load balancing module. So my name is Ashish and today we'll be continuing with the deployment or the configuration of load balancer on the AWS cloud. So before we directly jump on to part three, let us quickly understand what we have done on part one. So guys, I would really request you to watch the part one and part two before directly jumping on to part three. Because those two modules are very important for you to understand what exactly are we going to do in this part three. So in part one, we understood what load balancers are, what are load balancers, why they came into existence, how do we configure them, and what are they used for. Now, second, we also understood some of the industry, specific load balancers that are generally used. So they are, and before that, we also happen to understand what are L4 load balancers and what are L7 load balancers. Then, just after covering L4 and L7 load balancers, we quickly understood the three different types of load balancers over here. So one was NGINX load balancer. So NGINX load balancer sits on what layer? So absolutely correct. L7 is the correct answer. So NGINX sits on L7. Then there is HA proxy. So HA proxy is most widely used for production grade applications, or it is a very high choice for applications which processes a lot of real-time data, for example, stock market, banks and stuff. So this HA proxy load balancer sits on both L7 and L4. So we can configure it for both the use. And third one is AWS load balancer. So AWS load balancer has two load balancers. So one is ALB, that is application load balancer. So it sits on L7, and then there is NLB, network load balancer, that sits on L4. So this is what we covered on part 01, and moving on to part 2 of the load balancer series. So in part 2 was nothing theoretical. It was a hands-on lab on how load balancers are configured. So that was hands-on lab. So here we used NGINX as our load balancer. And what we did, we actually on our local system, we happen to create three fast API based applications, and we containerize them. So these are the three fast API based applications that we created, and we containerize them. So consider this to be server. So this is server 1, server 2, server 3. So these all are fast API and at the same time containerized. And then we have mapped all the three to different ports because they sit on the same host. So first one, host was 8001, and the container port was 8000, because container port, since all three are different containers, so container port could be same. So then this will be mapped to port 8002, and container port will be 8000, followed by the third one goes around 8003, followed by port 8000. Then what we did, we installed Nginx on our local system and we configured it, right? So this one was Nginx, and what we did, we configured Nginx to listen on port 80, and whatever request was coming down to Nginx, so it was routing to all the three different servers at the back end. So this is what we have done in our previous lab, right? So now we'll be taking this to the next level in the part 3. So in part 3 we are going to understand. So let me write part 3 over here. So in part 3 we are going to understand about AWS load balancer. The best part about today's lab or today's hands-on lab is like we will be trying to simulate entire, how a production grade application is actually deployed on the cloud and how load balancers are used to distribute traffic equally on those particular servers running in the backend, right? So what is going to be the entire flow of our application over here. So let me give you a brief and then we'll understand in detail what we are going to do. So first there will be a user. So user will send a request, and the request will go to AWS load balancer. So AWS load balancer is listening on port 80. Then it is going to go to target group. So target group again, knows instance at port 8000. I'll totally understand what are target groups, why we are using it. Just we'll understand the flow. So user sends a request to load balancer. Load balancer goes to target group, and target group has got a group of EC2 instances. So EC2 instances again receives traffic on port 8000, and then EC2 instances further goes to Docker container which is running on them. So Docker container, again, fast API listens on port 8000 inside the Docker container. And once the response, once the application or the backend is hit, then the request travels back in the same route, right? So this is the brief. Now let us understand what exactly we are going to do in steps. So in step one, we are going to create an EC2 instance. We are going to create an EC2 instance. Then we are going to install Docker. Then we are going to create fast API application, and then we are going to create an image of that particular application, create an image of that particular application, and post that we are going to run that application, and then we are going to access using public IP of EC2, right? So this is going to be one of the instance, and similarly in step two, we are going to create three more. So total we have four instances, right? Because we must be having multiple instances so that we can understand that how the traffic is being routed, right? So once four instances are created, then what we are going to do, we are going to in this step three, we are going to create a target group. So we are going to create a target group. So target group is one of the feature of AWS. So it is basically a collection of backend servers. So for example, let's say if I have got three backend servers, right? So this is server one, this is server two, and this is server three. So these three can be, grouped together inside a target group, right? So these three will be grouped inside a target group. Now, whenever any load balancer, if I have configured, and if I want this load balancer to be sending traffic to this particular EC2 instance, I simply have to map this particular load balancer to this target group rather than individually making the entries. What we have done in our NGINX video, if you had have seen our part 2, the NGINX load balancer. So there we have manually configured all the servers upon which you want to send the traffic. So it is super easy, super simple. Let's say if you want to add one more server, I can just simply add on this S4 over here and in this target group, and then load balancer will now start distributing the traffic among four servers. So this is what it does, right? And once this is done, then we'll be seeing that how the application is being accessed. So it is simple. User will come down. So user will send request to AWS Application Load Balancer, and the request will come down through port 80, and then it will go to target group again mapped to port 8000. Now this target group will have four EC2 instances, again listening on port 8000, and these EC2 instances will have four Docker containers, Docker containers listening on port 8000, right? So this is what the entire flow is going to be, and let us actually implement it now, right? So what we are going to do, we will quickly log into AWS console, and I'll sign into console. Okay, it shows actually already signed in. Why? Because I recently logged into this EC2 instance section, and here we have to create four EC2 instances. So three of the EC2 instances what I have already created, just to save time, and but I'll be creating a fourth one with you, right? Getting started through walkthrough, learn about, get started, launch EC2 instance without a walkthrough, right? So what we are going to do, we are going to write fast API LB04, right? And other details are going to be default. I already have a key pair. If you want to create a new key pair, you can just, type the key pair name. And if you are using a Mac, then you can use rsa.pem file will be downloaded. And if you are not using map, if you are on your Windows, then you can just create a ppk file that you can use or unlock using putty, and then you can log in. So I'll just cancel this because I already have a key pair. Let me put a key pair that is my fast API LB, and then allow SSH traffic, everything you have to keep default. We just want a system over there. Now we'll just wait for the EC2 instance to be launched. So let us see the EC2 instances over here. Okay, so fast load balancer 04 is in pending state. So let us wait for a while. And once this is done, then we'll quickly log into that instance. Let me just duplicate this. Okay, the instance is running. Perfect. Now what we'll do, we'll just get this public IP over here, public IP, and then what we are going to do, we are going to do SSH hyphen I, what is going to be my PEM file, fastapi.pem, and what is my user, EC2 hyphen user at the rate public IP, and it should log into the system. Yes, I am the authorized person to get inside. Please let me in, and actually I'm in. So what I'll do, I'll quickly do all the updates over here. So it is going to be sudo, that is super user, yum is the package manager, update hyphen y. So basically it will update all the packages which is going to require, which is going to be required in order to access the full potential of this particular VM or EC2 instance. So once this is done, the next step, as I said, is going to see Docker is installed or not. And by default, it is not going to be installed. So I'll just quickly check Docker hyphen hyphen version. It is not there. So we'll quickly put here our command. What is the command? Sudo yum install Docker hyphen y. So it is going to take a while, and then it is going to install Docker. So what I would suggest, everybody who is watching this particular videos, right? I would want you, if you are very much serious about DevOps, and if you just want to make a career in that particular vertical itself, then you should be very much acquainted with Docker. You should be running a lot of Docker files and then commands. Install Docker on your system, play with it, get your hands messy, and fail a lot of times, because unless and until you watch a video, you are not going to have that kind of practice or that kind of confidence that you will be getting once you have done it yourself. So Docker is installed. Let us check the version over here. Okay, so Docker is installed. Now let us check the status of Docker. So sudo systemctl status Docker. So let us check the status. It is off. Okay, let us start the Docker now. ART. Now let us check the status. Perfect, it is running. Now if I check Docker PS, it is saying not permission. Why? Because my user is not a part of this group. So what I'll do, if I check Docker PS now, it will show me the result. So let me add my Docker into this. So I will use sudo user mod hyphen ag, and then what is this Docker and what is my username? I have to add this user. So my user is EC2 hyphen user. So this is done, and I have to exit, and I have to re-log in. So now I'll be able to check the Docker command directly. Perfect. Now the next thing is we have to create a directory, and we have to create our FastAPI application. So I'll do cd app fast, and then I'll do nano main.py. So once I've done main.py, I have to just get this command. So I'll just quickly edit over here. Okay. Now I'll just, it's a very simple application. Basically, it will say hi from server 3 or server 4. So here it is going to be server 4 now. So it is basically going to say hi from server 4. So we understand that what server the response is coming from, right? So it is just going to print this. So this is how it is. Now Control X, Y, done. Now we are going to get a step back, and we are going to create requirements.txt. So we are going to do requirements.txt. So it has only got two dependencies. One is FastAPI and second is UVCon server, right? Control X, Y, get out. Now we are going to create a Docker file. So nano Docker file, and then we are going to copy this particular Docker file. Do not worry, I'm going to paste all this code in the description of this particular video, so that you have a hands-on to this as well. And we are going to save it, and then we are going to exit. Okay, okay, cancel. Mm, mm, mm. Okay, yes, and I have got everything over here. Now let us create a Docker file. Let me see, cat Docker file, is it there? Perfect, Docker file is there. Now what is the command? Docker build hyphen t, and what is the going to be my image name? It is going to be fast API lb04, and dot means current directory. So choose this Docker file from here. So Docker, once you happen to understand how does Docker image work, so it works in the form of layer architecture. So what do we exactly mean by layer architecture? So do you see all these commands here, from, working directory, copy, run? So these are the layer. Consider this to be layer 1, then this is layer 2, layer 3, layer 4, layer 5. So first it is going to do all the steps in this sequential manner, right? From Python 3.10 to this working directory, then copying all the elements to current directory, then installing everything from requirement.txt, then exposing port 8000, and then once everything is done, it is going to run our application. So everything is done. Let me check the image, Docker images over here. Perfect, I could see the image. Now let me run the application. So Docker run hyphen t hyphen D, that means the detach mode, hyphen P, what port am I going to expose? 8000 on the host and 8000 on the container. Post that, what is going to be the name of my container? It is going to be fast API container 04. Perfect. Post that, what I'm going to do, I'm going to use the image. What is my image name? Fast API dash LB my 4, right? Fingers crossed, container created. Let us check it is running or in exited state. Docker PS. Perfect. It is okay. It is in exited state. Let's see what is the issue. Docker PS hyphen A. Exited 12 seconds ago. Okay. Docker logs. 1B. Okay. Hello from fast API string. Literal declined at 4. Okay. Cat. Mm, okay. Cat app main.py. What does it say? Hello from fast API server 4 followed by instance equals to host name. But what exactly is the issue? Syntax error. Okay. Okay. What is the syntax error? No problem. Let me do Docker prune, Docker system prune, Docker system prune hyphen A. Yes. No, it did not work. I have to type yes. Why? Why? Okay, everything got deleted. Now let me quickly go into my different instances that I have created, and let's see what we have created over there. So I'm just quickly going to copy this IP, and I'm going to exit here. I'm going to use this particular IP. I have logged in. Now let us see cat app followed by main.py. I don't know what kind of issue was it showing now. Let me exit and then let me log into the new server now using the same. Okay, let us do the same command but with a different IP. Okay, okay. Now let me copy this entirely. Okay, let me do cd app rm-rf main.py and then nano main.py. Let us see, let us paste from fast API, and this is server 1. Let me just change the message from server 4. I hope this should not end up in an error. See, basically we could have corrected that error, but I do not want to, sacrifice time for that. Because we have to just complete this particular module as well. So nano, and I think we have got all the other files as well. ls, yes, everything is there. To create a Docker image, so we'll quickly create. First, let us see Docker images. Do we have anything? Nothing. So Docker build -t followed by fast API lb04 followed by a dot that is from current directory. So it will take a while. Let us just wait for a file to build the image. So it is extracting everything. Now it is going to install all the requirement that we have mentioned, the dependencies. Okay, done. Docker images. Okay, perfect. Docker run -d -p 8000 again by 8000 followed by name is Docker. No, fast API, right? Fast API container 04 followed by image name is fast API lb04. Let us see Docker ps. Yes, it is running now. And let us see if it is running actually. So if we copy this and if we go down here, port is 8000 as we have discussed. So, okay, it will not work. Why? Because we have not, configured this port of 8000 over here. It's very simple. We have to just go to security group and we have to just add a rule over here that allow traffic from 8000 as well. Custom TCP, put this 8000 and it should be anywhere IPv4 and save the rule. And once we save the rule, see, we got a message from server 4, right? Perfect. Now we'll just look into all the other instances as well, that how they are working, they would, or whether they are working or not. So let's go to instance number 1. We'll copy this. We'll go to this followed by port 8000. Perfect. One is working. Two more to check. So what do? We go to instance number 2 now. So this is 2 over here. Let us go to instance number 2, copy this. So I have created all the 4 instances in this similar way, the way I have showed you right away, right? So you can easily create port 8000 is here. Okay, now we can see from server 2 as well. Now what we are going to do, we are going to go to server number 3. Let us go to server number 3. Server number 3 is over here. Now let us copy this public IP. Public IP port is 8000 and done. So all the 4 servers are working. Perfect. So step 1 done. Now what we are going to do, security group is over here. Now instance, let it be here. Now we'll create a target group, right? Target group. So we'll just select target group and EC2 feature over here. So as I said, target group is only to, create a collection of EC2 instance so that whenever we have to do any load balancing work, we do not have to manually make an entries for all the, EC2 instances that we have got. So we can just directly point to the target group. So here we have to choose instance, and then we have fast API LB target group, and the port has to be 8000, and IPv4 rest all configuration remains the same, and then you have to create next, and then we have to select all, and we have to include as pending below, and then we have to next, and then we have to create a target group. So target group is also created. We'll just do a new tab over here, duplicate it over here, and then we are going to create a load balancer now. So you have to search for load balancer. So look for load balancer. So here load balancer, BAL. Okay, my spelling for load is wrong. That's why it is not LOAD. So load balancer, here you'll be getting two options, light sail feature and EC2 feature. You have to choose the second one, EC2 feature, and then you have to create a load balancer over here. So application load balancer is what we have to choose. Then we have to quickly write the load balancer name, which is going to be FastAPI, FastAPI LB, right? It has to be internet facing, IPv4, and then we have to choose the region. So if you see our instances, they are generally deployed on US West 2. So here we have to choose that particular subnet, that is US West 2A, 2B, 2C. So you have to choose any two. I'll choose all four, doesn't matter. Then security group is by default there, port is 80, forward, everything is there. Then you have to select a target group. So our fast API target group is over here. We have correct, and then we have to create a load balancer. So load balancer creation will take a little while. So once this gets provision, we just understand. Now we had done with a couple of steps now. So what exactly? So currently, if you just happen to understand, there are four EC2 instances. That is EC2 1. Then there is second one, EC2, EC2 that is 2. Then there is third, EC2 3, and then there is fourth, EC2 4. So all the four are mapped to port 8000 on the host and 8000 on the container. So this is applicable to all four. And application is running over here. Application is running inside. Now we have bound them. Using a we have tied them together using a target group. So this is a target group. So target group basically has grouped everyone together, and it is again listening on port 8000. And then now what we have created? We have created a AWS ALB, application load balancer, which is listening on port 80, and directly we are mapping this, because once the target group is mapped, all the inside load balancers that is currently mapped with this particular target group will automatically be mapped to port 80. So this is what we have done till now, and let us see what is the status of the load balancer. We'll just quickly refresh. It is still in provisioning. So configuration of this particular um, load balancer does take a little time. So we'll just quickly wait. And underneath this, there are a lot of other sections that we can go through. There's a resource map over here. So how the entire traffic is going to be routed to. And let us check if it is still in provisioning state. So load balancer takes a little time, as I said. So what is going to happen? So it will listen for HTTP request on port 80. Then there is one rule. What is the rule? Forward to the target group. And what is the target group that we have created? We have created a fast API LB target group. So here again, it is like it has got four targets over here. Port 8000, all the four instances will be listening on port 8000, and the container port is also 8000 over there. So now our load balancer is currently active. And what we are going to do, we are going to copy this particular fast API DNS over here. We are going to type HTTP and then this. Okay, perfect. So this is running. Now the request is from server 2. Let's refresh. Server 3, server 1, server 2. So our load balancer is working perfectly, right? So now if we see what is happening, so the request, let me change the color for you. Okay, let me change. Okay, let us use this color now. Okay, so the request is coming down on HTTP request is coming from port 80 and it is going to target group, and target group is equally distributing to all the other load balancers over here, right? Now, those who have watched my second video, part 2 video, we happen to create sticky session over here. So sticky session, what it does? So here also we are, we'll try to create a sticky session. So what does sticky session does? So sticky session basically, if a user is routed, if the request of the user is routed to, let's say, server 1, so even if this particular session has been cancelled, the next time when the user will log in, it will again route it to server 1 no matter what. So why do we do this? Because for example, the data are cached, and if the user is like, for example, if there is a shopping cart website, so user has spent, let's say, 10-15 minutes and got 10-15 items in their cart, and once the connection has been disconnected, everything is lost. So it is not a good practice, right? So the next time when the user logs in, everything, every detail should have been saved. So, and when will that be saved? When that request will be catered by the same server. So the similar concept is what we can see here in load balancer as well. So, but the sticky session is not here in load balancer. It has to be in target group. So what do we do here? We go to attributes and then we edit over here. And then the algorithm that is currently being used is called as a round robin. And here we have to create the stickiness over here. And I'll create for, let's say, 60 seconds now. Let me put it for seconds over here. And then I have to save the change. Okay. And I think I have to refresh this. Load balancer has to be refreshed. Okay, now let me copy this particular URL. First, let us see that how does it work over here. So do you see all the requests is getting to 4 now. Now let me do this over here. Again, it is getting to 4 itself. Do you see this? So our sticky session is working perfectly. That means my particular request has been catered by server 4 for the first time. So for the duration that I have said, the request will only go to server 4. Great. Now I'll just disable this sticky session for now. And the last thing what we are going to check over here is we are going to, let's go to attribute first, edit, and then turn off, and then save changes. Okay, so the changes have been saved, and now the fourth thing is what we are going to do. We are going to do a load test. So it is difficult for us, so for example, one refresh is one request, but load test means like we have to, do multiple requests simultaneously. So checking that or sending multiple requests simultaneously is pretty difficult. So what we are going to do, so we are going to artificially uh, put multiple requests. So what we are going to do here, let's say we have got 4 servers, right? Server 1, server 2, server 3, and server 4. So we are going to install, just like in video 2 or part 2, we have installed AB or Apache server over there, and then we have to, we faked request over here. So here we are going to install Hey. It is a similar kind of a setup as that of AB, Apache benchmark. So here we'll be installing Hey, and then here we'll be putting multiple requesting from here. This request will go to the load balancer, AWS load balancer, and that particular load balancer will be distributing the request. So this is the simple load testing that we are going to do, right? So we have to initiate a request right from here. It will go to AWS load balancer, and then load balancer will distribute that particular request. So there's a simple step. We have to log into one of the system. We are at 106. Let us say, hey, is it here? Hey, command not found. So we have to install Hey. So let us install Hey first. So here is the command to install Hey. We are going to install it manually. So here I'll be putting down a command. Okay, Hey is getting installed. Then I have to do. Then I have to assign execute permission over this system. Execute permission has been given. Then move the we have to change the file path, right? That is done. Now what you have to do, we have to just put up the command. So what is the command? So we'll put up this particular, copy this, and then we are going to put it over here, and then we are going to copy the load balancer DNS, right? So this is the fast API load balancer. Let us go to listener and rules, not exactly listener and rules. Let us go back, go inside the load balancer, copy this particular IP and put it over here, right? Let's see. Okay, perfect. Now let us see whether the request has been sent or not. So for example, we are at container 4, and what we'll do, we'll use docker logs 5c. Perfect. So these many requests were sent, and that is how the load got distributed, right? So what exactly did we do? So here, if you would see my command that I have pasted over here, here it says that I have to send 100 requests, and out of this 100 requests, send 10 requests at the same time to this particular load balancer, initiating from this server. So it has beautifully handled all these requests from here, and that's how the load testing is also what we have done. So perfect. So this brings down to the end of the video. So we have successfully, built a complete cloud-based load balancing setup. So this is how, in real time in production happens. There is a load balancer, then there is a, target group. And a target group has, let's say, hundreds of EC2 instances, which is a part of that particular target group. And then the AWS load balancer happens to send the request across the load balancer, and inside it gets distributed to all the other EC2 instances, right? So today we deployed a containerized FastAPI application on EC2 instance, registered them inside target group, and then let the AWS application load balancer handle the request intelligently. And also we used a Hey load balancing tool to simulate real time or traffic, and validate how the load balancer performs under load. So this is the exact architecture that is used by real companies. It is used for scalability, reliability, and fault tolerance, right? And if you want more AWS content, maybe maybe application load balancer versus network load balancer, or auto scaling group integration, or maybe ECS load balancing, so just drop in the comments. So this was our part 3 of the load balancing series, and let's keep building, let's keep learning. And one important part, those who have not watched the part 1, that is the foundation, and part 2, so the link will be just flashed onto your screen. Do watch that, and then watch this particular video. In that manner, you will have a great understanding about what all we have discussed. And thank you so much for watching this video, and I'll see you in the more upcoming videos, where we'll be discussing a lot of concepts in a very structured and sequential manners, and also with a lot of ease. Thank you so much for watching. Signing off.